Okay, this is the next example I want to work with you. So it's in the page 2, right? These pretty much are going to be the same thing, correct? So you have cosine, sine, and tangent. And remember the identities you have, right? We have the Pythagorean identity, right? Pythagorean identities. We have the half angle, the half angle, the pi over 2 shift, the negative angle, the definitions of the functions like tangent, cotangent, secant, and cosecant. Then these ones that are the Pythagorean identities, and then we have the ones we have been exploring. The sine of the addition or subtraction of an angle, the cosine, and the tangent. So with these three that you remember are right here in your formula booklet. So we have here the formula booklet, right? Is here, you see, all the formulas we are using are here. Definitions, graphs, negative angles, shift angles, the table from the unit circle again, and the identities we're using. The Pythagorean identities, then the addition, subtraction for sine, tangent, and cosine. And we're going to get these ones later, but they are going to be pretty much from these addition, subtraction formulas, okay? So not a big deal, right? So let's begin with this. So we have the first problem here. We have proved the next identities. We have, let me just page 32. We have cosine of x minus pi over 2 really is write the next expression as sine and cosine tangent of an angle. So we have to reduce this expression, simplify this one. So that's not a problem because here are the formulas we're going to use, correct? So we know that cosine of the difference is this one. So we have cosine of the first argument, cosine of the second argument, plus sine of the first argument, sine of the second argument. So this is going to be simply, I'm going to put it right here. This is going to be cosine of x times cosine of pi over 2 plus sine of x times sine pi over 2, correct? Now, it's very simple. Sine of pi over 2 is 1. So I have sine x, right? Cosine of pi over 2 is 0 times cosine x, correct? So I have to do a plus. So this is going to be simply sine x, okay? So what is the secret? Right here in these formulas. So you have these formulas at hand, right here. You easily go this one. Now what you need next? The values in pi over 2 on the angles you have, correct? So this is the first one. If you have, for instance, now, here is, if you have, for instance, now the sine of pi over 2 plus x, well, okay, this also can be simplified using the same formulas. Sine of a plus, you see the plus here, so what you have to do is do the sine of the first times the cosine of the second one plus the sine of the second one times the cosine of the first, correct? So you have here this one, and then, well, remember, what is the key to open these problems? Right here, you see? Here are the values, pi over 6, pi over 4, pi over 5, whatever. So this is sine of pi over 2 is 1 times cosine x plus sine times cosine pi over 2, 0. So if you perform this operation, this is cosine x. So you see, it's not a big deal. It's very simple. So let's apply identities to reduce the expression, correct? With the tangent, it's going to be pretty much the same, right? You have tangent of pi over 2 minus x. This is, well, for the tangent, I have this formula, you see, tangent A minus B. So what I have to do is just open this one. So this is okay. This is going to be, I'm going to put this one right here. So is tangent of pi over 2 minus tangent of x, right, over 1 plus tangent pi over 2 tangent x, correct? So, okay, let's see what happened here. Tangent pi over 2, that's going to be my problem. What is tangent pi over 2? Is okay. Let me just check. What is tangent pi over 2? It's okay. So I check my table, something you're going to do, and you're going to see that tangent of pi over 2 is undefined. It's undefined, that's bad. So let me just put it right here. Tangent pi over 2 minus tangent x, right? 1 plus, tangent pi over 2, correct? So what is going to happen in this case? This is, well, this is going to be the trick. I know that this is infinity, so tangent pi over 2 is undefined infinity. Oops, I have people trying to enter here, right? So I know that tangent pi over 2 is infinity, but I also know that 1 over infinity is a 0, so this is a number we can handle. And, well, this is going to be 1 over tangent pi over 2. This is a trick we're going to learn today. So if you have something that is undefined, try to switch it. So how do you switch this one? This is okay. It's going to be very simple, right? So what I'm going to do is this. I'm going to assume that this is still not 0, so I'm going to do this, okay? I'm going to take tangent A minus B equals tangent A minus tangent B over 1 plus tangent A tangent B. Okay, so I'm going to multiply times the problem. The problem is the first one, so I'm going to take 1 over tangent A, right, over 1 over tangent A. So what does mean this? Well, this is a 1, so this expression is the same because this over this is 1. But this is going to change my thing, so this is going to be, this times this is 1 minus tangent B over tangent A over 1 over tangent A, right, plus tangent over tangent, tangent B, correct? Okay, now with this equation right here, I'm going now to solve this one. So this is going to be very simple. So tangent pi over 2 minus x is 1, I have here the 1, minus tangent x over tangent pi over 2, right? 1 over tangent pi over 2 plus tangent x, correct? Okay. Now, this, remember, this is infinity, and if you divide something by infinity, this is a 0. So you have 1 minus 0 over 1 over infinity is 0, 0 plus tangent x. Okay, now this is 1 over tangent x. This is 1 over tangent x. And who's 1 over tangent x? Well, if you check in your identities, these ones, you're going to find that 1 over tangent is the cotangent. So this is cotangent x. Okay? So what was the trick? If you have an undefined, I can use the reciprocal of the undefined 1 over infinity is 0 to simplify my expression, okay? Okay? So this was a little bit more difficult than the previous two.
But very easy. I can see, Mr. Very easy.
Okay, let me just check the next one. This is page 2. Here we go. Okay. The next example we're going to solve here is the secant. Secant pi plus x, correct? It's obvious that this one has, right? There is an identity of this one, yes, but in my identities, I don't have a secant. In my set, I don't have secant, you see? Okay, so how can I just break this one if I have no secant? Well, I don't have a secant identity, right? But I know that the secant is the reciprocal of the cosine, correct? Or secant is 1 over cosine. So I'm going to use this one first. So this is 1 over cosine pi plus x, correct? It's going to be like that. Now, for this one, I'm going to use the formula for the cosine, you see? So I'm going to put this, all this thing under the 1. So this is going to be simply, let me just put it right here. Yep. You see this one? So this is going to be 1, and here I'm going to be cosine of pi times cosine of x plus sine of pi sine of x. So everybody catch what happened? So secant, I don't have secants here, but I know the secant is 1 over cosine, right? Basic identity. So right here, 1 over cosine. So I change this one by this one, and I open this one using this formula. Then I have to remember what is this. So this is 1 cosine of pi. Do you remember what is cosine of pi? It's negative 1 times cosine x. Sine of pi. Do you remember what is sine of pi? Well, you have to, because that's important, but in this case it's a 0 times sine x, correct? So these are going to be my numbers, correct? And, well, 0 times sine, 0, and this is going to be negative 1 over cosine x, correct? And 1 over cosine x is what? Negative secant x. So this is my reduction from this one. Secant of pi plus x is negative secant x after all this long operation with identities, correct? So again, here are the keys to open these problems, okay? So you have to keep this next to you and check which one you can use. Okay, let's move on a little bit ahead. So we have now combinations. This is, oh my, let me just see, but it's the same thing. So they gave me now this one. This is cosine pi over 7 times cosine pi over 5 minus sine pi over 7 times cosine times the sine pi over 5. This is, wow, this looks horrible, but no problem, because remember, you have to look which formula looks like the thing you have in front of you. It's okay. This looks like this horrible side right here. You see cosine, cosine, minus sine, sine. Okay, this portion looks like this one. And I know that this long thing is just this one. So I'm going to do A pi over 7, B pi over 5. And this is going to be simply equals cosine of pi over 7 plus pi over 5, correct? Pi over 7 plus pi over 5. Now here is the problem, because this is something you have to solve. So you learn in the elementary to do 1/7 plus 1/5. Remember, pi is something you can factor. So you have 1/7 plus 1/5. Okay, now we have to do our numbers To do these fractions, we have to do common denominator. So 5, 7 times 5 plus 7, 5 times 7, right? And this is 5, 35 plus 7, 35, correct? And this is going to be 12 over 35. So my answer is going to be, once you add these functions, cosine of 12 pi over 35. This is well. This one not necessarily is in your unit circle table. It's not there. It's a fraction, but, well, you don't have that angle right here, but this is the solution. So you simplify this long thing as just this value. So you have to simplify this long to this short, and whatever is this one and we need a number, we use a calculator, correct? So, but this is my answer. What I have to do, identities, and then elementary school math. I have to remember my fractions, okay? No excuse. Okay, Braulio. Okay. No questions here? Pretty easy? Okay, another like this one. Yeah, I have, let me just see. This is page 1, this is page 2. Okay, let me just try this one, tangent, right here. The next one, this is the one I solved, this is the next one I want, so I have, just write it. This is tangent 45 degrees minus tangent 30 degrees over 1 plus tangent 45 degrees times tangent 30 degrees. Now, I have to reduce that monster. Okay, no problem. I have my formulas to kill monsters. They are over there. So what I have to check is which one of these formulas is going to help me. This is okay. The monster, this looks like this right here. You see? And this thing can be simplified at tangent A minus B. Okay, not a problem. So the only I have to do is, okay, let me just put this here, right here. Yep, you see that? So this is this. So A is 45, B is 30. So this is going to be tangent of 45 minus 30. There is. You see? In reverse. 45 minus 30. Well, that's a 15. So this is tangent of 15 degrees. Now, tangent of 15 degrees is something you can find with a calculator, but this is my answer. Correct? I reduce this complex and horrible thing into this simple thing that can be solved with a calculator. Okay? No problem? Remember, here is the secret. Okay. Let me just now go to page 3. In page 3, you have pretty much to do the same thing. Page 4, pretty much the same thing, correct? So let's do some of here. For instance, A. So says, find the exact value of the next expressions. Okay, what is the expression? Okay, the expression is sine pi over 12 cosine pi over 4 plus cosine pi over 12 sine pi over 4. So this is the expression I have to simplify, correct? I get a value. So this is equals to what? Well, let's see. I have to reduce this in a single function. This is okay, let me see. Sine, cosine, cosine, sine, sine, cosine, cosine, sine. Okay, here is. This is a plus, this is a plus. So this can be changed by the sign of the addition of the two angles. Here is my formula. So this is going to be equal sine pi over 12 plus pi over 4, correct? Here is my formula. I'm going to use it. Not big deal. Now, okay, now fractions. Oh my gosh. Well, I have here 1 over 12 plus 1, 4. Remember, the pi is a factor that you can move out, not out of the sign chain, out of these two numbers. And then you have to add these ones. Okay, this is 12, these are 4s. So you have to change your fractions, 1/12 plus 3 times 4 times 3. So you multiply times 3, right, to get 12, correct? So you have 1 plus 1/12 plus 3/12, correct? And these are 4/12. And if you simplify, you get 4 times 1, 4 times 3. You cancel the 4s, and then you get 1/3. So this is basic math, okay? No problem with that. So this is going to be sine of pi over 3, correct? Sine of pi over 3. So this fraction simplifies to 1/3, so this is pi over 3. And the only you have to do is remember what is sine of pi over 3. So, okay, sine of pi over 3 is, you remember? No, yes? You have the table next to you? No? Is a square root of 3 over 2, correct? So that is what you have to answer. So all this expression that looks scary with an identity is reduced to this addition. If you do these numbers, this fraction, you get this simple number. And then this is in my number, in my unit circle. That's the answer, correct? No problem. Okay. Let's do another one. Let me just share the screen now. This right here. This is this one. So we solved this one already. We can do this one also, right? That's pretty much the same. Let me just try something a little bit more difficult, like the tangent. Let me just see the tangent, right? Tangent of 5 pi over 6 minus tangent pi over 6 over 1 plus tangent 5 pi over 6 tangent pi over 6. So I have to find a value for this expression. Okay, now remember, there are identities. You can change this expression that is very unfriendly to something better. So again, my formulas are right here. Now, this one right here looks like this one right here, you see? So if A is 5 pi over 6 and B is pi over 6, I can just subtract them and change with the tangent. So this is going to be tangent 5 pi over 6 minus pi over 6. Okay? How much is this? 5 minus 1. Okay, this is tangent of 4 pi over 6. You have 5, you subtract 1, you have 4. And if you reduce this fraction, this is tangent of 2 pi over 3. Correct? Now, what is pi of 2 pi over, tangent of 2 pi over 3? Okay, let's check. Yeah, right here. 2 pi over 3. Oh, right here. 2 pi over 3 is tangent is negative square root of 3. You see? Here is the 2 pi over 3 is negative square root of 3. So this is negative square root of 3. Okay, so you see the table. There is. So that's my answer. Okay. Pretty much the same is going to happen with all the problems in page 3. You see, find the exact value. So you have the cosine. You have here this one, sine of pi over 4 over x. Yeah, let me just solve the next one to show you. That is pretty much the same easy thing. So it's sine of pi over 4 plus x And then this is if sine of x equals 1/3, right? And the angle is between 0 and pi/2. So how much is this? So, okay, let's see. I need to use an identity. So again, I have here my identities. So this is sine of plus this plus this. Okay, sine of plus is this thing right here, you see? Okay, I'm going to use that. So this is sine of pi over 4 times cosine of x plus sine of x times cosine pi over 4, correct? Okay, now I have to know these two, right? Okay, sine pi over 4, you see your table. Let me just go back to the table, right? Sine pi over 4 is a square root of 2 over 2, and cosine of pi over 4 is a square root of 2 over 2. You see that here, correct? Okay, so I'm going to put the numbers back. So a square root of 2 over 2 cosine x plus sine x times the square root of 2 over 2. Now what I'm going to do is I'm going to factor this. So I have a square root of 2 over 2 parentheses cosine x plus sine x, correct? Now I have this one, sine x is 1/3, correct? So I'm going to plug in this right here. So it's okay, this is going to be, remember, this is equal, a square root of 2 over 2 cosine x plus 1/3. Okay? Now, you know only that cosine, that the x is between 0 and pi over 2. So you don't have anything else to do here because this x is not specified, it's on this interval. So this is open, there is no exact value for this one, like was for this, or for this that is given here. So this is my answer. Okay. In the last page, well, I have more problems like this, but I have to prove identity. So I have to move my complex expression into the simple one. This, 0, and so on. Let me just begin with this side. So these are the problems we're going to see. So right here. So right here. Let's begin with any of them. Let's begin with this one, sine pi over 2 minus x. All of them are going to be the same. So I have, let me just write on the board. This is sine pi over 2 minus x has to be cosine x. It's okay. Not a big deal. Right? So we have to prove this one. So, well, I have to move from here to here. I check my identities right there. You see? Okay, is minus, so is this one. So this can be sine, cosine minus sine, cosine, you see? So what I'm going to do is very simple. Okay, this is going to be equals, okay, it's going to be, here is sine pi over 2 times cosine x minus sine x cosine pi over 2, correct? So this is what I have. Now again, I have to go to the unit circle to find these values. So right here, sine of pi over 2 is 1, cosine of pi over 2 is 0. You can see that here, right? So not a big deal. This is 1 times cosine plus sine times 0. And obviously this is cosine x. So you prove your identity, correct? Another identity easy to prove because pretty much all of them are very easy, is the next one. So you have cosine of pi minus theta plus sine pi over 2 plus theta. This has to be 0, correct? So we have to prove this is true. Okay, let's see. I'm going to use my identity. You see I have cosine of minus and sine of plus. So, well, this is going to be a little bit long, but not difficult. So I'm going to expand this one. Cosine pi minus theta is going to be this expression right here. So it's going to be cosine pi times cosine theta plus sine pi times sine theta. And then I'm going to expand this one and I'm going to put it right here. So this is using this one, correct? So a sine pi over 2 cosine theta plus sine theta cosine pi over 2. So it's what I have here in my identities, is what I'm going to use here, correct? Same thing. Okay, now I have to put numbers to cosine pi, sine pi over 2. Cosine pi is -1, remember that, -1. So this is equals, cosine theta, sine of pi. Sine of pi is 0. 0 times sine theta. Sine of pi over 2 is 1. 1 times cosine theta. Cosine pi over 2 is 0. Sine times 0. Now, this cancel out, I disappear, and I have here negative cosine theta plus cosine theta. This minus this, 0. Okay? So you prove this identity using your addition subtraction formulas right here. Okay? This ones. Okay? Simple thing. Okay. The last one we're going to prove today is going to be, let me just use a different color. This is done. Sine x plus y plus sine x minus y is the same as twice sine x times cosine y. So we have to prove this identity. Okay. Remember, you move from the complex to the simple one because this is going to be simplified. So you go from left to right. So you have to do this and this, expand those ones using these formulas, correct? Okay, let's do the first one. So the first one is going to be sine x times cosine y plus sine y cosine x. And then I'm going to do this one. This is sine x plus cosine y minus, because there's a minus here, sine y cosine x. Now, you have to simplify these things. You see this one, okay, these two are the same, so you add them. You have 2 sine x cosine y, and these two are the same by different signs, so they cancel, plus 0. So my answer is 2 sine x cosine y. Exactly what you want to prove. So this is going to be another easy 100th, okay? Questions? No questions? Everything fine? So I'm expecting the homework. The homework is right here. Remember? Oh, not this one. So is this one. So you see problems. You can see here on the screen. Very similar, correct? Yeah, very similar to the ones I have solved. So this is going to be a very easy 100th.